Good afternoon and welcome, everybody. I'm Abby Bronson from PPMD, and I'm delighted to be able to introduce this afternoon's webinar on EduTromed and Summit's positive interim results from their PhaseOut DMD study. And we thank them for probably taking time out of their very busy calendars to speak with us this afternoon. And I'm also lucky to have a co-moderator today, Diana Ribeiro, who's the CEO of Action Duchenne. And she's going to be introducing our speakers in a moment. But first, before I hand the mic to her, I just want to go over a few housekeeping items for our webinars. So we'll have some time for questions at the end of the talk, and there's a chat box in your screen. So if you have a question, you can put that into the chat box. We'll try to answer as many questions as we can. And we have some already prepared that we think will be of interest for you. And any that we don't answer, we will answer by email after the webinar is over and post those that we can. The webinar is being recorded, so you'll be able to view it again at a later date, and we usually post on our website a couple days after, and we'll have these answered questions as well. So without further ado, I'll pass it over to Diana.
Okay, thank you very much, Abby. It's a pleasure to be able to co-moderate today's webinar in conjunction with our colleagues at Summit PLC. And the presenters for today are John Tindley, who's the Chief Scientific Officer at Summit, and Anne Hetherington, who is the Head of Clinical Development, also at Summit. So welcome and delighted to open the webinar.
Thank you, Diana. And this is Anne Hetherington, and on behalf of Summit, we are absolutely thrilled to be talking to you, the families that have stuck with us and helped us get to this point that we're able to share with you today. And I'd also like to thank Action Duchenne and PPMD for hosting this call and enabling this interaction to happen. So we really are excited to share these data with you today, and we look forward to the questions at the end. But before I get started, we are a publicly traded company, and I do need to remind listeners that we will be making forward-looking statements, and I refer you to our filings with the Securities and Exchange Commission for a description of the risks and uncertainties associated with an investment in Summit Therapeutics. So just as an overview, if we go to the next slide, please. Summit is a publicly traded company. It started life actually coming out of Oxford University in the UK. And amazingly now we have sites in Cambridge, in Massachusetts in the US, and also in Cambridge in the UK. So we have Oxford, Cambridge, Cambridge, which you can imagine adds to the fun in our offices. The technology that has driven Eutrophic was pioneered by Professor Kay Davies out of the University of Oxford. And she identified that Eutrophin and its modulation could potentially act as a universal treatment for DMD. So John's going to go into a little bit more detail. So sorry, if you could just go back a minute. John's going to go into a little bit more detail about Eutrophin itself. But just as an overview, we believe that Eutrophin has the potential to slow or stabilize the disease progression in all patients with DMD, regardless of their genotype. And this approach could be complementary to other approaches in DMD. And we are delighted that we could potentially bring benefit to a broad swathe of patients with Duchenne. We have partnered with Sarepta, and we are delighted that we have entered into that partnership because we're able to access their expertise from a regulatory viewpoint in many other areas. And we do have regular discussions with them. And they will be, if we're successful in marketing the drug, Sarepta will have European rights to our Eutrophin modulator pipeline.
Okay, thanks, Anne. So I'm going to briefly go over a handful of slides here to try and remind people or newcomers as to what Eutrophin modulation is, how Eutrophin is different to dystrophin, but more importantly, how similar Eutrophin is to dystrophin. So the slide here, the top half is a sort of a diagrammatic representation of the dystrophin protein and the eutrophin protein. And the important point is that essentially they have the same color schemes. So at one end they're able to bind the internal cytoskeleton of a myofiber. At the other end they're able to bind into the proteins which is in the membrane of the myofiber. And they have this set of repeats, which is what gives the structural integrity of these proteins, but importantly gives them this action as being almost like a molecular shock absorber. So as fibers contract and relax, they do this in a regulated way to keep the fibers from damaging themselves. And one way of looking at this is, sorry, if you can go back. So one way of looking at this is imagining a trampoline. So the trampoline is a cross-section through a muscle fiber. So the mat is the internal workings of the fiber. You have the membrane and you have the springs. So if you imagine dystrophin or eutrophin are these springs. And the important point here is there's a fixed number of springs to give the trampoline its maximal function. But as you start to take away the springs, you can still have some function, but it's obviously not as good as having all the springs. And if you take all the springs away, then the trampoline loses all of its function. So you can see the importance of the numbers of springs, the amount of dystrophin, or in our case, the amount of eutrophin, to give you some functional benefits. Can we move to the next slide? So I've said that eutrophin and dystrophin are similar in their functional capabilities. So what is the difference? And the main difference really is simply when these two proteins are expressed. So eutrophin is expressed very in early development in all muscle, but it's also expressed when a fiber is damaged for whatever reason and a repair process starts to generate a patch to repair that fiber. So on this diagram from left to right, we have a fiber which is either regenerating, it's been damaged, or it's, as you see, in very early development. So you find that eutrophin is expressed and it's bound to all these very specific sites. And as time goes on and the fiber matures, you have eutrophin being switched off and the dystrophin protein is switched on. So over time you eventually have all the binding sites are occupied now by dystrophin, and eutrophin has been turned off and is not present. Next slide, please. So this is how we envisage for DMD. So the eutrophin gene is naturally expressed in DMD boys. So what happens in a fiber that's repairing itself is that eutrophin is turned on, which is part of the repair process, and is able to occupy the sites and protect the newly forming fiber from damage. And then naturally it's switched off again. However, now there is no dystrophin that's present to be able to bind to these sites, so after a period of maturing you have a fiber that has no eutrophin and importantly no dystrophin, so this fiber then goes back into this cycle of trying to repair itself. If we go to the next slide, so this is how we envisage eutrophin modulation. So this is the idea that we want to break the natural cycle of eutrophin expression such that it's not only present when a fiber is repairing itself, but is present the whole time in these fibers. And therefore, if we have eutrophin at all these binding sites, we believe that we can have a very functional fiber, even in the absence of dystrophin.
And so before we get into the actual clinical trial, we really want to thank all these organizations and patient groups for supporting Summit in reaching this stage in our development. And you can see here that PPMD and Action Duchenne have been very much part of this journey with us, as have other foundations listed here. And we look forward to continued collaboration with these organizations moving forward. So the Eutrophic clinical program, like many, is divided into a number of different phases. And you can see that phase 1 is generally focused on addressing the safety and toleration of a molecule. And in the case of ezetimibe, that's exactly what we did. We assessed ezetimibe in over 100 healthy volunteers and 22 patients with DMD. And we established a very good safety profile for the molecule. And we also used it to assess different formulations that you know that we have brought into the current phase 2 study. So after understanding the safety and the PK profile, we moved into phase 2 and we started the PhaseOut DMD study. And the main objective of this study is really to understand if ezetimibe can indeed modulate Eutrophin in patients with DMD and replicate the findings that we've seen non-clinically with Professor Davies in her lab. Additionally, we wanted to understand if ezetimibe could have a positive effect on the biomarkers of muscle structure and health. John talked you through there how Eutrophin is able to be a biological substitute, we hope, for Dystrophin. And so we're looking at the biomarkers to see if that's really the case. And as we move into future trials and much longer term trials, as you all know, what we really would like to see is ezetimibe having a positive effect on muscle function and also on the activities of daily living. And can we measure that in terms of quality of life measures? So with that, I'd like to just take a few minutes and talk you through the design of our phase 2 study that we're talking about today. It is an open label study, so all subjects receive active drug. We have enrolled 40 patients across sites both in the US and in the UK. And all subjects undergo the core part of the trial, which is a 48-week treatment period. And at the end of that 48-week treatment period, all subjects have the opportunity to roll into an extension phase, which will continue until either ezetimibe is approved or its development is discontinued. We divided the study into cohorts 1 and 2, as most of you know, and that was really around the different formulations that we used. And we will be initiating a third cohort, also known as the safety cohort. And that cohort is really to meet our commitments to patients and families that participated in prior summit trials. And they'll be able to have the opportunity to enter into PhaseOut DMD imminently, actually. Within the study, we're measuring a whole range of endpoints. And starting at the bottom, the first thing we're going to be looking for is Eutrophin engagement. We have collected biopsy samples, 2 samples per boy in this study in order to assess whether we're able to measure and modulate Eutrophin. The next thing we're looking at is muscle health. And again, we're going to use the biopsy samples to do that. And we have a number of measures that John's going to talk us through to assess that, to include looking at developmental myosin, a marker of regeneration, as well as fiber diameter. And as we move on in time, really, in terms of how long we expect these actions to take, we are assessing the muscle health using an imaging technique, MRS. And using that, we're able to measure how much fat has built up in the muscles of the boys and whether over time we would have an impact on that. And lastly, of course, we're measuring the functional endpoints that you're all very familiar with. And one thing I'd really like to emphasize here is the rigor that we've put into the assessments in this trial. And even though it is an open label study, we actually have blinded employees at Summit to the data, and we only unblinded ourselves to support the 24-week readout, and we're now all blinded again to the subsequent data. We've also put in very rigorous processes around the collection and shipment of our biopsy samples. And we have, for our MRS endpoints, we have worked with leading experts, the Imaging DMD group, to ensure we have rigorous assessments there. So I just want you all to understand that we really take these results and the effort that your families are going to deliver these data very, very seriously. So moving then, so actually this is John. Could we go back a slide, and John's going to talk to you now about some of the results.
Okay, so this is a focus on the biopsy measures, and the biopsies have been very important to us because they've allowed us to answer key questions at this phase for ezetimibe. So can ezetimibe modulate Eutrophin, and what effect does that have on the muscle structure and health within these biopsies? So for the 24-week assessments, we focused on 3 measures: Eutrophin expression, where we saw an overall increase; developmental myosin. So this is a biomarker which identifies a repairing muscle fiber. And in this case, we saw a significant decrease in the numbers of repairing fibers at 24 weeks. And also we're interested in muscle fiber diameter, where we saw a small overall decrease. So the 24-week samples were all compared to samples taken at baseline prior to the patients receiving Eutrophic. As Anne said, we had a very rigorous collection, and analytical methods were validated and put in place prior to the analysis work done on these biopsy measures. And because of all this rigor, all biopsy samples contributed to the overall 24-week data set. And very simplistically, to analyze the data, we trained a computer to read each biopsy section. This removes all the human subjectivity, it ensures the data quality, and it allows us to evaluate, on average, several thousand fibers in each cross-section from the biopsy. So the next slide, please. So firstly, here we're looking at Eutrophin. So these plots, you can see baseline and week 24. So this is looking at the overall data that came from the biopsies that were taken from these boys, comparing their baselines and their week 24. We observed an overall mean increase in the Eutrophin intensity of around 7%. So Eutrophin went up. And what you also have to remember, which the baseline demonstrates, that in these boys there's already a high level of Eutrophin observed, because, as I've already said, that a lot of damage is trying to be repaired by the presence of Eutrophin as fibers are repairing themselves. And this is normal, this is part of the natural damage repair cycle. But because Eutrophin is usually present during muscle repair, we need to know whether the Eutrophin that we see in our biopsies on each of these fibers is there for repair, or is actually present because azutamide is keeping Eutrophin production turned on. Go to the next slide. And so this is where developmental myosin reduction becomes such a very important observation for this study and has given us such great excitement. So just like Eutrophin, developmental myosin is present during normal muscle fiber development, but also the repair process. So you can almost imagine that developmental myosin and Eutrophin are expressed at the same time and in repair. So what this slide shows is the white is essentially marking where developmental myosin is being expressed, and so this is an increase in age from a 9-week fetus all the way through to a newborn, and you can see, just as it would be for Eutrophin, that it's expressed at high levels in lots of fibers, then over time it's turned off. And the bottom panel just shows you an example of what you see in DMD muscle. And I said, because of all this repair, you see lots of fibers which are positive for this biomarker. If we can go to the next slide. So what this image is actually data from an individual boy that was in the study, showing you the difference between the baseline and the week 24. So here, the blue areas is a fiber that's showing evidence of repair because it's making this developmental myosin. And by eye, you can see the reduction in the amount of blue positive fibers going from the baseline to the muscle in week 24. And so this is what the computer is able to identify and quantify and generate data, which, as I say, has is not influenced at all by any human operators. So what does this mean? So here we see the data for the total population in the study. So we're looking at the absolute change in the percentage of developmental myosin positive fibers. And so in the baseline, on average, there's around 11% of all fibers are positive for this biomarker. And after treatment, again for the whole population, there's a fall of the numbers of fibers which are positive for this marker. And this is statistically significant. This is a significant reduction across the population. And the mean decrease across the population is around 23%. So there's a 23% fall in the numbers of fibers that showing evidence of repair. We can go to the next slide. But what does this mean? So we believe this reduction in muscle damage is meaningful. And the way that we have being able to look at this is part of the validation studies that were done developing these assays. So we had a number of biopsy samples from a biobank. Some of these were from Duchenne boys, and some of these were from Becker patients. As many of you know, the Becker patients, on average, have a less severe disease. It's not as progressed as the Duchenne patients. And what we're able to observe is as the number of positive myofibers in this group are calculated, you can see as you move from left to right, as the disease becomes less severe, as you move from a Duchenne to the Becker group, you see that the number of positive myofibers for developmental myosin falls. So we believe that this demonstrates that the biomarker of developmental myosin presence in a fiber, as that falls, is evidence that there's less repair going on in these muscles. And this significant decrease in the developmental myosin, we believe, could lessen the disease. And what we have to remember is we're seeing this fall in regeneration, yet we're not seeing any real fall in eutrophin. So this would suggest that we're now seeing a Eutrophic modulation, so repair of fibers is falling, and in the non-DMD case, eutrophin levels should also fall, but they don't. They remain stable and increased. So we think these two pieces together demonstrate that we are seeing true Eutrophic benefit in these biopsies.
Thank you, John. And so I'm going to move on and talk a little bit about some of the other measures that we assessed in the study. Now, to be clear, when we decided to do the 24-week interim analysis, it really was the biopsy endpoints that we were focused on because we felt they had the most opportunity to see changes really just at the pathology level. And we really feel that 24 weeks is too early to see changes either in fat fraction or in the functional endpoints. But for the purposes of transparency, Summit's committed to sharing these data with you and sharing them publicly so you have access to the information. So the MRS is similar to MRI insofar as we can look inside the muscles of the leg and measure the fat fractions and also the extent of inflammation within the skeletal muscle. MRS actually is a more sensitive measure, and where we're looking at fat fractions less than 25%, MRS is a better technique and a more sensitive technique to measure those fat fractions. And you can see here what we saw. We saw an increase from a baseline of about 15%. It went up about 3.5% over 24 weeks. Now, even though there's still an increase in that fat fraction, actually, if you look at the literature, you expect an average increase maybe of coming up near 10% per annum. And so we think this data sets us up well to be able to see things as we approach the 48-week time point. We're showing you here also the results of some of the functional assessments, including the 6-minute walk distance and the North Star ambulatory assessment. And you can see the changes that we've observed at 24 weeks. And most importantly, all patients in our trial retained ambulation over this 24-week treatment duration. And we didn't see any clinically meaningful functional declines in the patients across the duration of the study so far. We do expect that longer-term dosing to have an impact on these outcomes, and we hope to see changes at the 48-week time point in these. I'd also like to point out to you that ezetimibe has continued to be well tolerated. I told you that from our phase 1 program, we had a very good toleration profile, and that has continued in these 40 subjects over the time period that we have been evaluating ezetimibe here. And very interestingly, and very importantly, there has been no apparent difference in either the safety parameters or any of the muscle parameters between the two formulations that we've tested in this study. And when we've looked very closely at the plasma concentrations, what we have seen is that all patients have achieved plasma levels of ezetimibe that we believe are sufficient to modulate eutrophin. And so that is in keeping with the observation that there There's no obvious differences between the formulations here at the data we have to date. So, to summarise what we've seen, we within Summit and our close collaborators that we're working with are very excited about these data. It really is the first evidence of an impact that Eutrophin modulation could have in the muscles of boys with DMD. We believe we've seen true evidence that ezetimibe is active, and as John pointed out to you, that's a combination of a decrease in the developmental myosin and a maintenance and maybe even an increase in Eutrophin at the same time. These data are very encouraging to us, and we believe they set us up to see meaningful differences in the MRS parameters at the 48 weeks. And we will continue to monitor that. We will be able to look at the 36-week time point as well as 48-week time point when we share those data with you later in the year. And we will be working closely with collaborators on natural history data to enable us to put these data into context as we move forward. So, what's next? We will continue this trial. We are excited to continue this trial. Our patients are continuing towards the 48-week time point, which will occur later this year, as we said. And we're expecting to share those data with you in the third quarter of this year. Our extension phase is also continuing, and the vast majority of our patients, as we reported in our press release, have chosen to continue into the extension phase of the study. And that data will be critically important to us as we evaluate the impact of ezetimibe over 18 months, 24 months and longer of dosing. And that will help us put all the data into context for the shorter term and the longer term benefit. At the same time, we're also considering our regulatory options as well as the design of our pivotal trial. And we've started working quite extensively to think about what that trial should look like, how quickly can we get it started, and obviously the design of that trial will be influenced by the 48-week readout of PhaseOut DMD, but we are continuing our pace to get that study designed and engage with all the relevant people to help us make the best job of that we can, including the patient organisations who we've consulted with actually quite recently to help us with the design of that trial. So please keep in touch with us. Michelle Avery is our patient advocate, and she is available to help answer questions for you, and we've given you here our website, and we very much look forward to our continuing collaboration with you, your families, and the patient organisations as we go forward. And before I finish, before we start to answer the community's questions, I'd sincerely like to thank all the patients and families that have been involved, not just in the PhaseOut DMD study, but in the prior studies that we've conducted before this one. And you really are helping to bring what has the potential to be a universal treatment for DMD to the market. And with that, thank you very much.
Thank you very much, John and Anne. That was very interesting presentation and great results, very promising results. I think we have some questions here, and I think, Diana, do you want to start with the first question?
Okay, great. So thank you very much for the presentation. So we have 10 questions, and we have categorized them according to 3 categories. One was around the biomarker about myosin, one was around Eutrophin, another formulation and functional tests and future trials. And what we have done is ensured that the questions have been from a wide geographical distribution. So the first question is, can you explain what the clinical significance of a reduction of myosin in the muscle that you have seen in these results?
Okay, so I'll take this. So as we showed in the slides, if you look at disease severity, where you say that Duchenne on average is a worse disease than Becker, and you actually quantify the percentage of fibres that are repairing themselves, or the percentage of fibres that are positive for developmental myosin, you see there is a relationship that as the disease severity reduces, then the numbers of repairing fibres reduce. And so I think what we see in our study is that even after 24 weeks, we see there's a significant downshift in the numbers of fibres that are repairing themselves. So you can imagine over even longer periods of time that this reduction in damage to fibres will allow muscle to be potentially have greater function, and then that will start to show itself in the other endpoints that people look at, particularly the functional endpoints.
So continuing on sort of in that discussion, and you had stated in the presentation, also in the press release, that all patients achieve plasma levels of azithromycin sufficient to modulate Eutrophin, and now we're hearing that sort of theoretically Eutrophin goes up, developmental myosin goes down. So why did only 14 of the 22 patients show a decrease in developmental myosin? And so I guess it seems like if they achieve the plasma level required, wouldn't they have all shown some decrease?
Yeah, that's a very good observation and a very good question, of course. But with all clinical trials, there is variability. I've worked in clinical development for about 20 years, and when we see spectacular results, we always forget that what we're looking at is the average results, and the average results can look very good. It's quite rare for companies to share individual level data, as we have shared with you today, and so you're able to see that granularity, that 14 of 22 responded. But that is the variability, and we expect that over time, we expect and hope, I guess, that all patients can benefit from azithromycin, and we'll continue to evaluate this over time, and we'll see in the biopsies from the 48 weeks of treatment how this is performing at that time point.
Right. So maybe there's individual patient response, and some of those are going to respond later on, and we have to wait for the 48-week data.
Exactly. We'll just have to see how that plays out, indeed. Thank you.
Okay. Thanks.
So similarly, with regards to myosin as being a potential biomarker in the future, do you tend to validate myosin as a biomarker? And can you explain your work in fast-tracking other Eutrophin biomarkers to the clinic? And are you validating myosin in the EU via the European Medicines Agency and in the US, the Food and Drug Administration?
So the first step in any of these processes is to make sure that you have robust, analytically validated assays. And as John talked about earlier, we have done that. We've taken great pains to work with our collaborator Flagship in making sure all the assays that we use for the biopsies are analytically validated. So that first step has been undertaken, and we're confident with that. The second step then is to make sure that the regulatory agencies agree with our analytical validation. And we've had positive discussions with both the FDA and EMA on that front, and so we are continuing those discussions. The third step is the one that you're referring to, which is, and can you validate these as biomarkers? We will continue those discussions, but what we need are functional outcome data in order to even put that proposal forward. So we will continue to gather that data, and as the data emerges, we will see if we have that option ahead of us.
Thank you. So the next question, actually we're jumping to the next topic. It's about Eutrophin. And I think the community has heard about Eutrophin upregulation and Eutrophin modulation for years, and we're so excited to see some of these results. But I think there's some previous papers, and there was an expectation that, we needed a 200% level of normal to that azithromycin might increase Eutrophin up to that level, and that amount might be needed for clinical benefit. So now we have the results of 7%, and I know it's very early, but how do you sort of reconcile that? Just give us some color around that sort of discrepancy.
Okay. So So I think you're right. It was interesting when you first said about eutrophin regulation or eutrophin modulation. So what we've been keen to try and get across to the community is that we're not talking about upregulation. What we're talking about is the ability to maintain a level of eutrophin expression continually so that the fibers have some level of eutrophin at the membrane. Now, a lot of the publications that you see about eutrophin, they will quote in their experiment how much extra eutrophin or what level of eutrophin they saw after their intervention, whether it's ourselves with azutamid or other things. I think that's just really is just a factual observation rather than saying that's how much you need, because nobody's ever looked to try and titrate how little you need the way that you can for dystrophin. And what I wanted to try and get across also from the presentation is this idea that within a muscle fiber there's a sort of a finite amount of dystrophin that you need to have full function, and if you take that away you can still have function until you take it almost completely away before you lose absolute function. And we feel that eutrophin is exactly the same thing. So if you could maintain continual eutrophin expression such that it's 10 or 20% of what that fiber could naturally make, then we believe that would still have a significant benefit, just as we know from what's out there in the community that levels of dystrophin like that you can envisage would be also very beneficial. So I think it's important to try and move away from this idea that upregulating it to a certain amount, but really it's the maintenance of its expression, and depending on how much you maintain, then you may start to see better and better results. And I think this also then gets back to the idea that there may be a time element. So for some of the myosin where we saw significant falls, then maybe that in that case that individual is a better modulation in some of them where myosin has remained stable. But in those individuals in a longer period of time with a lower level of eutrophin modulation, they will also then start to see the benefits.
Okay. That makes sense. Hey, Diana, do you want to go on to the formulation question?
Yeah, so great. So there are two questions on formulation. Can you explain the differences between the formulations in your wider pipeline and go through the timelines for each?
Of course, and actually this is a good opportunity because I realise that this is a rather confusing point for people, and I appreciate the opportunity to clarify some aspects here. So to start with the current trial, PhaseOut DMD, we are testing one molecule, eutrophic, in two different formulations, being referred to as F3 and F6. But it is the same molecule that we're testing, just presented in two different ways. In terms of the broader pipeline, we are continuing our collaboration with the University of Oxford, and we are seeking to bring forward new molecules that potentially might represent best-in-class for eutrophin modulation. I'm unable to give you clear timelines at the minute, except to tell you that they are in discovery at the minute, and that we are continuing to bring forward molecules and to test them in our non-clinical studies. And when we're ready to share more information on that, we will. But that work is continuing in collaboration with Professor Davies at Oxford.
So, in continuing on, so that's sort of like the wider, the next generation azithromycin. So, just looking at the F3 and the F6, and you mentioned that there was cohorts 1 and 2 each had the different formulations. Is that correct?
Yes, that is correct. Cohort 1 had 30 subjects, and that had the F3 formulation, and Cohort 2 had 10 subjects, and that had the F6 formulation.
And so how do the different formulations differ? I don't know if you can, what is the differences between those two?
Physically, the F3 comes as a liquid, whereas the F6 comes as a powder that needs to be made up in a liquid. So just from a physical viewpoint, that's what it is. But the reason we introduced, the study was started with the F3 formulation because we felt we had enough evidence to support that the F3 formulation would give blood concentrations sufficient to drive Eutrophin modulation. However, we weren't absolutely certain that was the case. So the company put a lot of effort into improving the formulation and obtaining higher blood concentrations. And that work resulted in the F6 formulation, which was introduced into the study later. Now, as it turns out, our first hypothesis was correct. It appears that, indeed, the F3 formulation is able to achieve concentrations suitable to modulate Eutrophin, because in every way we've looked at the data so far, and that's not to say that there might not be something in the future, but in every way we've looked at the data so far, we haven't seen any differences between the responses driven by either the F3 formulation or the F6 formulation.
So the individuals who had a really good decrease in developmental myosin, you couldn't make a conclusion about whether they were, on F3 or F6. It was they're equivalent, basically, the two formulations.
That's correct. There was no rhyme or reason to it, to be honest.
Okay.
And we are continuing to investigate that. We're continuing to understand why that's the case. But the bottom line principle that we're coming back to is that that both formulations give sufficient concentrations to modulate Eutrophin.
Okay. And so, I would think, so you're going to have to choose one to go forward with and actually bring to market. And if they're equal, would you choose the liquid? Maybe I can't ask that, but just it's something interesting to think about.
Yeah, no, absolutely. And we have put a lot of thought into that. And actually, we are in the middle of developing our commercial formulation, which will be a powder. And the plan is to introduce that later in the year. So that sets us up with a commercial formulation so that we're ready to go into our pivotal trial with our commercial formulation.
Okay. All right. Well, thank you. That was a great explanation. So now we want to move on to some questions about the functional test results that were in these interim results. And I know, 24 weeks, you can't tell that much, but I think this is a question that came from the community, is that, the functional data, which showed small declines in both 6-minute walk test and the North Star. And then you talked about the positive myosin results and the Eutrophin going up, myosin going down, which is all positive. So do you think that you just need longer time for this functional test for the trends to reverse? Or is that, obviously that's what you're hoping to expect? Can you comment on that?
Of course, happy to. So when we set this out, we always have thought about the effect as a cascade. That the first thing we would see is around Eutrophin engagement. The next thing chronologically we would see would be maybe an impact on the muscle health and regeneration. And over time then we could see an impact on the larger scope of the skeletal muscle itself and the functional endpoints eventually. So that was always our expectation. And as I'm sure many members of this community know, that to see differences in functional endpoints at 6 months has never been demonstrated before, and possibly even not at 12 months either. So we did not expect to see changes in either the MRS or the functional endpoints. As I said, we are reporting those here out of transparency. Mm-hmm. What we are optimistic about, though, is when we compare these data to some of the literature data, that we are kind of on the right side of the decline. And I don't think any of us expects to be able to reverse the amount of fat in the skeletal muscles, unfortunately. But what we do hope to do is to slow the decline or to stabilize that decline. And that's what we'll be looking for at the week 48 results.
Okay. Yeah, no, we appreciate very much the fact that this is early data, and you've been very transparent in talking about these sort of exploratory points. So another question that came in relating to the functional test is that would we be able to ever see the individual functional data for the 22 patients by age? Because I think that's interesting to the community because, some of the older boys might have been approaching or declining more than some of the younger boys. So that was something that people were wondering about.
So we we have not done that analysis ourselves yet. We are continuing to delve into these data every day. And once we have more information to share, we will share it, and we plan to share information at meetings over the course of this year as we develop it.
Okay, thank you.
Great. So the final two questions, and which always generates a lot of interest, is particularly when you have an early signal and you have some interim data, is a lot of the community and families and young people living with Duchenne always looking at future trial opportunities. And so those are the following two questions. And the first of which is, my son will be 12 years old next week. He is still fully ambulant, only using his wheelchair when we are walking long distance. Would he be eligible to be included in the next round of trials, as I'm aware that in previous trials the maximum upper age limit is normally 10?
So I hear the question, and all I can tell you is that we are actively working on the design of that next study. We did meet with a number of patient organisations to get input on that nice and early. We are working with some of the experts in the field, and we will roll that out when we're able to, but we will be looking at our inclusion-exclusion criteria very, very clearly to make sure we optimise it to get the best trial that we can next time round.
Are you able to give us some timelines with regards to when, would it be this year or next year, as to when that trial will potentially be open, and the design of which?
Unfortunately, not just yet, but some of you may have heard our CEO talk that we're putting our planning on steroids, is what he told me. So we will bring that forward to you as soon as we can.
Okay. And the last question is, what were you thinking in terms of the design of your next trial? Will you use the same endpoint and include a non-ambulatory arm?
So our next trial, I think we've talked about the next trial and that we're working on it. But in terms of non-ambulatory, we are looking at what else should we be planning for in this population? As most of you know, we're required to put in a pediatric implementation plan, a PIP within Europe, and actually within our PIP, we are looking at a wide age range to study with Eutrophic as we move forward. So it may not be in the pivotal study as we move forward, but we are most certainly looking at the non-ambulatory population as well as other populations in our planning at this stage.
Okay, great. So I think
can I ask one more question? That's just an explanation of something you said on your last slide, and it came up in a question. I think you can probably talk about this a little bit, because you had mentioned that it might be available as conditional accelerated approval, and I think, can you just explain that a little bit? I think that was in the last slide, number 20.
Yeah.
Okay.
Yeah, that's totally fine.
Thank you.
If you design a trial and you use an endpoint that you discussed earlier, whether we would seek to have the biopsy endpoints recognized as validated biomarkers, for instance, you could consider that maybe the MRS endpoints might be considered that way. If you move forward with an endpoint that's not considered a phase 3 registration endpoint, what you're asking the agencies to do is to give you accelerated approval in the US or conditional approval in the UK. So if our primary endpoint was not a functional endpoint, that is the way that the approval would work. And the intention is that perhaps you can see those endpoints move faster and that you can get to market and get the drug available to patients earlier. So we're looking at that. So we're looking at every option right now. So it may be that we use a surrogate endpoint, or it may be that we use a functional endpoint. Either way, we'll be looking to optimize that design so we can get to marketing authorization as quickly as we can.
Okay, and that's certainly what we want to happen too. So thank you very much. Yeah. Any last minute comments from John or Anne? Well, if not, I think we're going to close out this webinar. I know there's some more questions in the chat box, and we will take any that we didn't answer in the conversation, and we will answer them in writing, and we will post them when we post the webinar. So, Diana, any last thoughts?
Yeah, I think there were some great questions and lots of interest. So it's really, really fantastic to see the number of people living with Duchenne across international community log in large numbers, and there's been some great questions on the chat box. I think it will be great looking forward to following up with PPMD and Summit on the FAQ document, which I think will be really valuable, because I think it's been great outcomes as a result of this call, and it's been really great to hear some of the progress and what your future plans are.
Yeah, we hope that we're going to get another webinar like this in 48 weeks with equally positive results. So thank you very much. All right.
Yeah, we'd like to thank you to everyone, and thank you to the community for your support. We too look forward to sharing the 48-week data with you later in the year.